our e-learning. Did you try to do?
Yes, doctor.
Okay. Okay, so this I will just try to prepare all of you from the topics that I delivered, which is from week 1 until week 8. Okay, so I prepared to all of you around 6 questions. Okay, covered from topic 1 until topic week 8. Okay, uh, mostly for my questions in your final exam will be calculation based, and a few explanation question. Okay, you need to calculate, and then at the end you need to justify, or you need to explain. Maybe you need to choose, maybe you need to give a reason, okay, which one is the best, for example. Okay, so let me take a look into the first question. Okay, please wait for a while. I need to connect the air server to my laptop. Question. Okay. Okay, so suppose that everyone already downloaded our exercise for today. So for the first question, okay, before we start our class, do you have any topics that you need my extra explanation, my explanation? Do you have any topics, subtopics from week 1 until week 8? Do you have any topics that you want me to explain? You can hear me, right?
No, Doctor.
Tak ada, eh? Okay. If no questions, okay, let me try to do for the first question, the exercise. Okay, determine the output for the highlighted pixels using filters, using 3x3 windowing. Okay, so actually, if I give you this sub image, okay, or this figure 1 image, this is the intensity. And then it's mentioned that I need you to get the output for the highlighted pixels. Okay, the highlighted pixels is actually the center one, which is 255. So it depends to the equation. Some if I put 255, if I put the highlight pixels over here, sorry. Okay, okay. This is the center. This is the highlighted pixels. Okay, it depends to the equations. If the equations highlighted these pixels, meaning that you need to get the output for these particular pixels. Okay, so the highlighted pixel for these equations is actually this one. Okay, so why I mentioned it 3x3 windowing, meaning that we can try to calculate to get the output for each of the filters depending to the windowing size. If 3x3, please remember the value that need to be used is just this particular region. Okay, if the question is asking you to do for 5x5, okay, for example, for this question 5x5, meaning that you need the intensity that you need to calculate to get the output is the whole image. 5x5. Okay, that one is it okay? Okay. So if the first question is asking you to get the output for 5 filters, okay, based on this region, which is a 3x3 region. So the one that involved in your calculations is just this 3x3. Okay, 20, 20, 25, 25, 255, 20, 20, 25, 25. Okay, maybe a few of you saying that this question is very simple. I know it's very simple. However, a few of you still making mistake. Okay, they confusing which intensity need to be used to calculate. They're missing up the method itself and so on. Okay, so for the first average filter, okay, is the name of the filter is average. For sure, we will be calculating the average for that particular region. Okay, so if you calculate the average for this intensity, meaning that you will be calculating, for example, here using 3x3, okay, meaning that 20 plus 20 plus 25 plus 25 plus 255 until plus 25, okay, divide by 9. Because we use 3x3, so the total number will be 9. Okay, so you'll be getting one value. That value is actually the output for this particular pixel. For example, this is the output image. Okay, so we are calculating here. Suppose that this is 3x3, this one. Okay, so suppose that we are calculating just for these particular pixels. Okay, meaning that at these particular pixels. Okay, so anyone already calculated the value? Can you share with me the value for average filter?
48.33.
48.33. So if this is intensity, so you can round it into the nearest integer, which is 48. So the value is 48, which will be the final output for this for the pixels in the output image. Okay. So that one is for average filter. If the calculation for the second questions here, asking you to calculate for 5 by 5 windowing. For 5 by 5 windowing. Okay, if the 5 by 5 windowing, meaning that you need to use all of this value, 5 by 5 windowing, 20 plus 60 plus 60 plus 25, 25 plus 25 until plus 60 divide by 25 because we are using 5 by 5 windowing. Okay. Okay, the next one is maximum filter. For this filter, whether it's maximum or minimum, it is the easiest one. Okay, meaning that from this region, you need to find out which one is the maximum intensity. For sure, the maximum intensity is 255. So the output will be 255. Okay, so if you're using this filter, maximum filter, to remove, for example, these pixels is actually a white noise or salt noise. Okay, if we are using maximum filter, meaning that after calculating, the value remain as 255. So meaning that maximum filter is not suitable to be used in order for us to remove the salt noise because the final output remain the highest value, which is 255. Okay, so if you have white noise or salt noise, what you can propose is you can propose to use minimum filter. Okay, so the next one is contraharmonic. Do you still remember how to calculate contraharmonic? Contraharmonic. Harmonic. Harmonic, if I'm not mistaken, Mn divided by summation 1 over intensity. Summation 1 over intensity. So for harmonic filter, okay, for harmonic filter, Mn here is your windowing size, which is 3 by 3. Right now, we know that is 9. Okay, and then divide by 1 over 20 plus, right now we are using 3 by 3, okay? Divide by 20 plus 1 divide by 25 plus 1 divide by 25 until plus 1 divide by 25. Okay, so you need to do the summations over here. So you'll be calculating 9 divided by the total summations over here. Okay, so you'll be getting one value. Can you share with me the value after calculating the 9 divided by this value?
24.73.
24.73. Okay, so we can round it to the nearest integer. We can round it into 25. Okay, so make sure you because the equation for simple filtering we will not give during our examination. Okay, during your final exam. So you need to memorize this formula. Okay. Okay, the next one is contraharmonic. Okay, contraharmonic. Still remember what is the equation for contraharmonic? Anyone? We have Q value. Okay, please remember different Q value will display a different output image, meaning that some Q value less than 1 indicates suitable for what kind of noise, bigger than 1 is suitable to what kind of different noise. We'll be using different values of Q. Okay. Okay, let me take a look into the equation for contraharmonic filter. Contraharmonic. Okay, so the equation for contraharmonic is summation GST, which is Q plus 1 divide the summations of GST Q. Okay, the full equation you can take a look into through your lecture notes later. Okay, so based on this, for example, we use 3x3 windowing. Okay, we use 3x3 windowing. Okay, meaning that we have 20, for this is for the above equation, 20 power of, right now Q is negative 1.2 plus 1. Okay, so 0.2 plus 20 power 0.2 plus 25 power 0.2 until the end, 25 0.2 divide by, okay, so this will be Q, meaning that 20 power of negative 1.2 plus 20 power negative 1.2 and so on. Okay, so and then at the end, you just divide these two, you will be getting one value. That value is the final output for this particular pixel after using contraharmonic filter. Okay, for those already calculated, can you share with me the final value for contraharmonic?
23.71.
23.71. So I can say that we can round it into 24. Okay. Okay. Last but not least is median filter. Okay. We know that median filter, you need to arrange it into whether it's increment or decrement order. Okay. For 3x3, meaning that we have 9 values. So 9 values. So we need to take the fifth one. Okay. For this one, we have 1, 2, 3, 4, 5. Okay, meaning that the center value will be 25. Okay, so you need to, suppose that you need to sort it into increment or decrement order, and then you select the 5th location. Okay, so that indicates the median value. Okay, so I'm quite sure everyone can calculate and get the final output for this value. Okay, the tricky part is, okay, based on all of this, the value that you get over here just now, okay, maybe the question will ask you which one is the best to remove this, for example, this salt noise. Okay, so based on the value that you get over here, you can suggest, you can explain which one is the best. Okay, for example, just now maximum filter is not suitable. Okay, so maybe average filter is good, is better. Okay, or median filter is better. It depends to your explanation. For example, if you choose average filter, it has drawback as well, because in general, if you use average filter, it tends to produce blurry image. Okay, blurry image. Okay, both value is quite similar, 25, 24. Okay, however, average filter may produce blurry image. Okay, so maybe you can propose, or you can choose median filter, because median filter is will not having blurry images. Okay, so after you calculate this one, maybe the next question will be asking you choose which one is the best. Okay, when you choose, that one is you need to explain why you choose the methods. Okay. Okay, so for question number 2, okay, for question number 2, suppose that you need to do similar steps, similar calculation. However, the intensity that will be used in order for you to calculate it is actually this whole intensity, rather than just 3x3. Okay. Okay, for those already calculated for question number 2, can you share with your friends? For average filter, what is the value that you get for question number 2? Anyone already calculated?
56.4, Doctor.
Sorry?
56.4.
56.4. Okay, you can round it to 56. Maximum filter is 255. Okay, harmonic mean filter?
Saya dapat 0.0978.
0.0978. This one is I think it's not correct.
I get 33.49.
33.49, is it?
Ah, yes.
33? Okay, so we can round it into 35 as well, 34. Okay, control harmonic.
31.
31. Median filter.
7.
25.
25. Okay, let me check the final answer. Filter. Okay, the first one, average filter 56, correct. 33.49, okay, correct. The control harmonic also correct. The last one also correct. So the one that your friends share with us actually is the correct answer, all of this. So for those that yet to calculate, yet to do your exercise, you can try to do, and then you can compare your result with this final answer, okay? Okay, so the next one is, okay, determine the okay, this one is already discussed. So the third one, determine the output for the highlighted pixels in figure 2. For example, this is our highlighted pixel. By after implementing unsharp masking and high boost filtering, when k equal to 1.1 and we use 3x3 windowing. Okay, so you need to remember step by step what to do when we implement unsharp masking and high boost filtering. Okay, for the first step, what you need to do? Unsharp masking and high boost filtering.
Find the mean value, Doctor.
You need to smooth the image first. Okay, when you try to smooth the image, you can use, for example, here you can use average filter. Okay, if you use average filter, the value will be
52.78.
52.78. I can round it into 53. Okay, 53. Okay, so the next step, we need to get G mask, right? The mask. So for G mask, the original intensity is 60 minus 53. Is it correct? In order for us to get G mask.
Yes.
Okay, so you'll be having 7. Okay, so the final output image is your original image plus this will be your, this will be, okay. So your original image plus the K value is 1.1 multiplied by your G mask, which is 7. Okay. Okay, so 60 plus this 7.7. Okay, so you'll be getting 67.7 is your final answer after implementing unsharp masking and high boost filtering. Okay, please remember if K is bigger than 1 is high boost filtering. When K equal to 1 is known as unsharp masking. Okay, so you need to remember how to, step by step to calculate. Okay, so sometimes, okay, so unsharp masking and high boost filtering. Okay, so sometimes maybe I will not give you, I did not ask you to calculate step by step. Maybe I will give you the value for fxy, the value for the smooth smooth value, okay, maybe you need to proceed from that particular point. Okay, so anyhow, you need to know step by step what to do if the questions ask you to do unsharp masking and high boost filtering. Okay, so the next one is, okay, we know that beside unsharp masking and high boost filtering, we also have Laplacian filter, Laplacian kernels. Okay, the Laplacian kernels, it can be like this, or it can be like this, or it can be like this. 1, 1, 1, 1, -4. The rest is 0. Or we can have like this. -8, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so we can have different sequence of different value for our Laplacian filter. So, however, you need to know how to calculate the final output if the questions ask you to implement Laplacian. Okay, so here, do I have to include 3x3 windowing? I don't have to include 3x3 windowing in my equations, since inside these Laplacian kernels is already 3x3. That's why I do not include using 3x3 windowing or 5x5 windowing, because we know that this kernels is actually already 3x3 windowing. Okay, so if this pixels is the center pixels, okay, the center pixels, meaning that the region that you need to use to calculate is just this region. Okay, it's just this region. So this will be your kernels. Sorry. Okay, so based on this, you just convol, which is 20 multiplied by 0 plus 20 multiplied by -1, 25 plus 0, 25 plus -1, and so on. Okay, so the final output will be getting one value, which is the final output for these particular pixels. Okay, as you can see here, mostly I will be asking you to calculate 1 pixel. For example, if I highlighted 2 pixels over here, if I highlighted 2 pixels, meaning that 50 and 14 over here, meaning that if you move to the 14 pixels over here, the value that need to be used to calculate is this one. Okay, meaning that 20 multiplied by 0, 25 multiplied by -1, 25 multiplied by 0 plus, and so on. Okay, so it depends to the question which pixels that I ask you to calculate. Okay, so this one is for Laplacian filter. Depending to the kernels that is given, you are supposed that you will be able to calculate to get the final output for this particular pixels. Okay, so okay, suppose that this one unsharp masking. Okay. Okay, so let me take a look into the next question, which is question 5. Okay, for this one, we have 2 kernels. Okay, 2 kernels. Okay, this the given value. This is the given value. Okay, suppose that this given value is already 3x3, and this kernel is also 3x3, meaning that is just strict calculation for 40 multiplied by 0 plus 40 multiplied by -1 by 150 multiplied by 0. You add up everything, you will be getting one value. Same goes if you use these kernels, you will be getting one value. Okay. The next question that I can ask you is, okay, based on these 2 value, which one will be producing a strongest response? Strongest response. Okay. Based on this, anyone already calculated? Can you give me the final output for this kernel and this kernel?
330 and 550.
330 and 550, right? Okay, so based on this value, suppose that if the value is higher, meaning that it will be giving you a strongest response. Okay, so between these two kernels, okay, this kernel will be producing a stronger response because one, it produced the higher value. Okay, why? Because actually we give the highest value into the center. Okay, so this is how you choose which kernels can produce the highest, strongest response. Okay. Okay. So that one, I want you to try to search more. Okay, how to defend your answer if you have two kernels, which one is the best? Which one will be producing the strongest response? Okay, that is your homework for today. Okay. So last but not least, okay, these questions, did Dr. Daniel ever discuss with you for also thresholding? Anyone? 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 My question is, did Dr. Daniel ever discuss how to calculate also to get a threshold for also thresholding?
No.
No. Okay. So for this one, this is you need to try to do. Okay. 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 Let me try to do. So so tak ada orang yang try to calculate this one? Ke ada yang try?
Tak ada doktor.
Huh? Sorry? Tak
Tak ada
try.
doktor.
Okay. Okay. So let me try. Stop sharing. Okay, I want you to know that this also thresholding is very important. So everyone, you need to carefully take a look into the explanations or the calculations that I will share with you. Okay, so when you did your lab session, you try to call a function in order for you to do also thresholding, right? Okay, actually, beside the function, actually we have a calculation, the algorithm that calculating to produce one threshold value. Okay, so I will explain to you step by step how the algorithm works in order for also thresholding to produce one threshold value. Okay, when you do your lab session, it's very easy. Call a function, and that is straight away will be producing one threshold value. However, beside the function, how it works. Okay. Okay, so this one is your, okay. Okay, so the main idea of also thresholding is it try to maximize the between class variance, which is here. Okay, so for also thresholding, okay, so for example here, I'm quite sure I cannot ask you to calculate if I give you 8-bit images, meaning that you need to calculate, for example, from It's too tedious process. Okay, maybe I will be just give you just 3-bit images. Okay, meaning that from intensity 0 until 7. Okay, so for example here, if this is for example this is L. Okay, if 8-bit meaning that 0 until 255. If 3 bits meaning that 0 until 7. Okay, so MN is actually your total size of image, which is your row and columns. So if you have row and column, for sure you know how many pixels for your image, how many the size of your image. Okay, so the first step that you need to do is you need to try to normalize the values. Okay, take a look into your the question just now. Okay. Okay, so here is your histogram. Mostly as your histogram. Okay, take a look here. So you have intensity 0, 20 pixels, intensity 100 pixels, intensity 2, 120, 120, and so on. So your total MN is total number of pixels. You can sum everything here. So it will be your MN. Okay, so this is your M. Okay, can you share with me the total pixels for MN?
600.
600. Okay, thank you. Okay, so based on the slides that I showed just now, you need to get the normalized value, right? So it will be easier for you to have, for example, here, this is a new column. Okay, so you need to have a normalized value, meaning that Ni divide by your Mn, meaning that you'll be getting 20 divided by 100, 100 divided by, 600, 120 divided by 600, 80 divided by 600, 50 divided by 600, 120 divide 600, 50 divide 600, 50, 60 divided by 600. Okay, so you'll be getting the normalized value. Okay, this one, the first step is very easy since we already did in histogram equalization previously. Okay, so anyone already did here? Can you share with me the normalized value?
0.333.
0.333, is it?
In front got 1 0.
Okay. And the next one,
1667.
0.0667, is it?
1667.
1667. Okay, next.
0.2. 0.1333.
Is it like this? Okay.
And 0.0833. 0.2. 0.0833. 0.1.
Okay. Okay. Suppose that it will be good for you if you standardize the value, not like I am writing right now. So if you standardize in three numerical value, stick with 3 numerical value. Okay. For example, here. Okay. Okay. So we already have normalized value. Okay. The next step is, okay, based on this equation, okay, take a look into the equation. Also very well known. Okay. So determine the between class variance for k equal to 4. Okay, for your information, for also thresholding, it's actually the algorithm, how the algorithm works. Suppose that it will try one by one, meaning that it will try, for example, 0 and 1, we assume it to be one region. The rest will be one region, meaning that we set k equal to 1, meaning that, the threshold equal to 1. Okay, meaning that if the threshold equal to 1, meaning that intensity 0 and 1 will be one group, intensity 2 until 7 will be in one group. That is the first they try to do. Okay, and then for the next cycles, it try to have different cluster, 0 until 2, 3 until 7, 0 to 3, 4 to 7, meaning that it keep repeating doing this iteration. Okay, for each iteration, it will be producing one value which is between class variance. Okay, each of the iteration, it will be producing between class variance. Okay. However, for questions, I will not ask you to do each iteration. It will be tedious. Okay. So I may ask you just to do if k equal to, for example, the question k equal to 4. Meaning that if the questions ask you k equal to 4, okay, k equal to 4, meaning that it will look like this. K equal to 4 will be one group, group 1. 5 to 7 will be in group 2. Meaning that we try to separate 0 to 4 will be one group, intensity 5 to 7 will be one group. So we will try to calculate and producing between class variance. Okay, do you get my explanation, everyone?
Yes, Doctor.
Okay.
Yes,
So,
doctor.
the next one, okay, this is, suppose that we need to do step by step, 0, one group, 1 to 7, one group, 0 to 1, one group, 2 to 7, one group. However, it will be tedious for you to do all in your examination. So that's why I will ask you just to try to do for one cycles. For example, here k equal to 4. If k equal to 4, meaning that 0 to 4 will be one group, 5 to 7 will be in one group. Okay? So the next step is you need to calculate P1 and P2. You can refer to your to our slides later. Okay, you need to calculate for P1. P1 and P2. Okay, so right now we have 0 to 4 as one group, 5 to 7 as one group. Okay. Okay, so P1 is actually, the calculation will be summation I equal to 0 until k. K right now is 4. Okay, and then Pi. Pi we already calculated just now, which is the normalized value. The first step that we did previously. Okay, so for example here, P1. Okay, P1, you will be adding up this normalized value from 0 until 4, meaning that 0.033 plus 0.166 plus 0.2 plus 0.133 plus 0.083. 1, 2, 3, 4, 5. 1, 2, 3. So you'll be getting the value of P1. Okay. For the next, for P2, okay, you can add up, for example, 0.2 plus 0.083 plus 0.1, or you just 1 minus the value that you get over here. It will be the same value. Okay. Until this point, is it okay?
Okay, Doctor.
Okay. Can you share with me the P1 and P2 value? Can you try to calculate P1 and P2?
0.616.
0 point
616.
616, and then P2
384.
0.3
4. 384.
384. Okay. Okay, so you'll be getting these two values, P1 and P2. Okay, so this is the second step. Okay, the third step, what you need to do is, okay, you need to calculate the mean intensity value for each of the class. Okay, we have P1 class, we have P2 class, right? So we have P1 and P2. Okay, right now we need to calculate the mean value. So how we can calculate it? 1 over 0.616, which is P1. This is for P1. This is for, I can say that it is for class 1. This will be class 2. This is class 1. This is class 2. Okay. 1/616. Summation I equal to 0 until K right now equal to 4. IPI. Okay, IPI. So what we need to do, 1/6. Okay, summation, meaning that, for example, 0, I is your intensity, multiplied by 0.033 plus 1 multiplied by 0.1667 plus 2 multiplied by 0.2 plus 3 multiplied by 0.133 plus 4 multiplied by 0.083. Okay, so you did the summations over here and then divide by 0.616. So you'll be getting M1. Okay, for this one is M1. M1. Same goes to M2, the average for M2, the average for group 2. Okay, 1/0.384. Okay, and then the summation will be 5 multiplied by 0.2 plus 6 multiplied by 0.083 plus 7 multiplied by 0.1. So you'll be getting M2. So you already have P1, P2, M1, and M2. Okay, until the third step, you get it, right? Okay, later you can try to calculate. Okay, so the next step that you need to do is you need to have global mean value. So for sure, you already have P1, you already have M1, you already have P2, you already have M2. So MG, suppose you can get it because the value is just fill in the blanks that you get previously. Okay, so 1, 2, 3. This is the fourth step. Okay. Okay, the next, okay, this is global mean value will be P1 M1 plus P2 M2. You will be getting MG. This is mean global. Please refer to your notes as well, mean global. Okay. So this is just fill in the blanks. Sorry. Okay, you already have P1, you already have M1, you already P2, you already have M2. So you just fill in the blanks, you'll be getting MG. This is the fourth step. Okay. Okay, last but not least, you can calculate the between class variance. Okay, the between class variance is symbols like this, okay, in your notes, equal to, this is the equation, P1 M1 minus Mg power of 2 plus P2 M2 minus Mg power of 2. Okay, this is just fill in the blanks. You already have P1, you already have M1, you already have Mg power of 2, you already have P2, you already have M2, you already have Mg power of 2. So here, you'll be getting one value. For example, you'll be getting 3.61, some values. Okay, after you calculate between class variance. Okay, that is the final step to get the between class variance. However, this between class variance is not your threshold value. It's not your threshold value. This is just the value between class variance. Meaning that if you have sorry. The one that we calculate just now is just between class variance for K equal to 4. I will remove this one first. Okay, for example, this is between class variance. Okay, this is between class variance. So the one that we calculate just now, for example, the value is 3.61. This is just a random value that I assume. Okay, so k equal to 4 just now, we have 3.61. Okay, so this is the value of between class variance value. Suppose that this is not your threshold value. Please remember, this is not your threshold value. Okay, suppose that you need to calculate for each of the iteration, meaning that, for example, I did calculate 0, 1 group, 1 to 7, 1 group, I get 0.18. This is between class variance when I calculate it. And then I will be getting, for example, this is 1.18, 2.13, 6.78, 0.13, 0.14, 0.11. For example, this is the value of between class variance. Okay, so which one, if you we already completed calculating all of these, okay, so which one is the threshold value? The one that maximize the between class variance, meaning that based on here, the maximum value is actually this value. So the threshold value for this particular equation is actually value, the threshold value is actually value 3. Okay, so the one that I explained to you to calculate step by step just now is just to get between class variance, the empty slot which is over here. The one that the highest value in between these is actually indicates that the intensity for this particular, the highest one is actually the threshold value. Okay, so for example, if this is the threshold value, meaning that your thresholding function will be if fxy is less than 3, the other one is 0 to 55. If fxy is bigger or equal than 3. So meaning that this 3 is actually your threshold value. Okay, do you get my explanations, everyone? Is it okay? Dah senyap dah? Is it okay?
Okay, Doktor.
Okay, so I'm quite sure a few of you yet to try to calculate it. Okay, you try to calculate it first for just, okay, for the questions that I give to you, actually you can calculate all of this, meaning that you can try to do several times. Okay, for example, the questions asking you for k equal to 4. For sure, the one that I teach you just now is k equal to 4. However, if you want to get the threshold value, okay, this is just for exercise for all of you. So you can try to do multiple times just to increase your what you call exercise for you. Okay, you can try. You group it 0 as one group, 1 to 7 as one group, and then you can try the next cycle 0 and 1 as one group, 2 to 7 and one group. You calculate a few times, and you will be getting this value. Okay, so based on the value that you get from your calculation just now, okay, actually you can select which intensity is the threshold value. Okay, for this question, for sure, I just ask once iteration, one cycle. However, if you want to do more exercise, you can try to do a few times depending to your group class. 0 as one class, 1 to 7 one class, and then you keep repeating, changing the group. Do you get what I'm trying to explain, everyone?
Doktor, boleh ke kalau Doktor terangkan balik yang selepas step 5 tu?
Step
Kan
5 tu.
Doktor kata tu tak threshold value. Lepas tu saya tak dapat tangkap dah.
Okay.
Sorry Doktor.
Tak apa. Okay, so last step tadi we get between class variance, right? Okay, between class variance that you get just now is just for k equal to 4, meaning that if k equal to 4, it's actually just for this particular location. Just now, for example, I get 3.61. For example, this is just a random value. Okay, So this one, 3.61, is between class variance. The value is not a threshold value. Okay, it's not a threshold value. Why? Because the between class variance is totally different value. Threshold value is totally different. Okay, how we can get the threshold value based on also thresholding? Okay, suppose that you need to we need to calculate a few times. Okay, meaning that you need to calculate 0 as one group, 1 to 7 as one group. Okay, 1 to 7 to one group, and then 0 to 1 as one group, 2 to 7 as one group. So you need to calculate a few times. Okay, for example, if you calculate 0 and as group 1, 1 to 7 as group 2, so you'll be getting one value which is between class variance. For example, I get it as 1.61. Okay, and then for the second cycle, I try to calculate 0 to 1 as one group, 2 to 7 as one group. I'll be getting between class variance, for example, 0.81. So I need to calculate. Suppose that if I want to get the threshold value, I need to calculate for each of these sequence. Okay, for example, I get 1.37, 6.13, 0.1, 0.1, 0.12, for example. Okay, so based on these, all of these value, okay, we need to select the highest one. Okay, for example, the highest one is this one. So the threshold value reflected is actually this intensity value. 6.13, which is the intensity, which is intensity 3. So actually this is the threshold value, not this value. Okay, so the one that I explained step by step is just to calculate between class variance. In order for you to get the threshold value, you need to calculate all of this. Okay, the highest one indicates the highest between class variance over here. The one that indicates the threshold value is actually the intensity over here. Do you get my explanation?
Dapat, Doktor.
Okay, so that's why I ask you, I give you the equations actually here for k equal to 4. So actually you can try to do a few times. For example, k equal to, for example, 0 as one group, 1 to 7 as one group. So you'll be getting between class variance for this one. So you calculate everything here and then you can know which one is actually the threshold value. Okay. Okay, so you can try to do this one first. Okay, I will share with all of you the detail, the result between class variance result for each of these one. Okay, and later you can check whether your calculations is similar with the one I calculated. Okay, just to make sure you do this exercise to make sure that you remember. Okay, the steps, you need to remember the equation as well. Okay. Okay, so the next, okay, this is, I'm quite sure if you try to do this exercise, it helps you in your final exam later. However, the one that I mentioned just now, you need to check, maybe you need to explain, maybe you need to choose. That one is actually, you need to understand the fundamental. Okay. For this, the next step is the next questions that the next task that I give to you is, for example, the one that we have Laplacian different kernels. Okay, which one is the strongest? Why you can say that it is strongest response? You need to find out that one as well. Okay, and then last tip for you, it will be good if you can revise back these slides. Let me take a look here. Okay, you take a look. You also need to revise, do revisions for these particular slides. You get share presented. Okay, you see, right? These slides. Okay, the slides. Okay, some of the maybe I ask you to calculate, for example, linear. I ask you to calculate power law, and then I may ask you which one is the best, why this one is the best, why this one is not the best, and so on. Okay, Sometimes, okay, this one you need to be able to explain, you need to be able to choose which one is the best. Okay, so do your revision on this slide as well. Okay, any more questions before we stop our class for today? I think the calculation part, I recovered everything. Just to make sure that you can answer with higher marks, you need to be able to explain certain things, the one that I mentioned just now. Okay, why the strongest response, this one, these kernels having the strongest response, and so on. And then the slides that I show with all of you as well, you need to be able to explain why gamma is good compared to the rest, compared to log, compared to negative transformation, and so on. Okay, any more questions that you want to ask me?
Doktor, kalau dah masuk test, masuk lagi ke dalam ini?
Masuk test for just for histogram equalization part, we already included in your midterm exam. So the calculation part will not in your final exam. Okay. However, if is explanation part, maybe you need to propose histogram equalization, it may be in your final. Okay, just the calculation part is not included for histogram equalization and so on. Is it okay? Clear?
Okay, Doktor.
Okay, any more question? Yeah, yes. Okay. Region growing. It may you need to for calculation part, it may not included in your final exam. However, for explanation part, it may be included. Okay, for those that covered by Dr. Daniel, I'm quite sure he already covered everything. Okay, for week 1 until week 8, mostly calculation part. Okay, however, you as I mentioned before, I have a few questions that is asking you to explain, to choose, to compare, and so on. Okay. Did I answer your question? Okay. Okay. Any more question?
Doctor, your part is mostly calculation, right?
Yes.
All right, thank you, doctor.
Okay. So in Dr. Daniel part is mostly theoretical part. Okay, that one you need to read a lot. Okay. Okay, before I end our class for today, this is a reminder to all of you. Okay, you're 4th year student, right? You know that if we catch you cheating during your examination, okay, this it is a very serious what we call very serious issues. Okay. Okay, for your information, if you're in UM, if you're in certain university, okay, during my time, if you caught cheating, you bring something in your exam hall, although it's not intentionally. Maknanya you tak purposely nak buat masuk, terselit. Okay, if we get that notes during your exam, terselit dekat tangan, terselit dekat paper, okay, we need to report it. Okay, so if your students, if you're previously if you're UM student, awak akan digantung pengajian. Okay, you'll be getting all of your subject for this semester will not be calculated. Aku akan digantung pengajian. Okay, so I think right now in UNIMAP also it is serious matters, a serious issue. So please make sure before coming to your final to your exam hall, no notes in tak ada apa-apa notes dekat awak punya badan bawa masuk dalam exam hall. Okay, if you caught cheating using ChatGPT or asking your friends outside to do to search for you, okay, if we report, you may get suspend, you may get, I'm not sure, this is depending to the pegawai perundangan UST nanti. Okay, just I want to highlight, do not try to cheat during your exam. We already give you everything. Okay, we already guide you everything. I'm quite sure if you read, if you study more, you don't have to do any trying to sneak around your papers, sneak around your notes and so on. Okay, any question? This is a reminder to all of you. Okay, any more question? Okay, I will be sharing with you. You try to do first. Okay, the last question. I will be sharing with you the final between class variance values. Just you can recheck with your answer later. Okay. Any question? Tak ada
No,
question?
Doktor.
Ah.
Doktor, calculation tu memang fokus yang exercise kita buat hari ni je. Kalau yang dalam e-learning yang exercise dengan tutorial 1 tu tak payah.
Itu apa ni tutorial 1? Tutorial 1.
Yang kita buat sebelum midterm test tu.
Like I mentioned, histogram, equalization semua tu tak masuk dah kan? Calculation. Tapi calculation lain, maybe you need to take a look log transformation basic yang slide yang saya bagi tak set tu. That one you need to focus calculation part maybe and then the explanation part as well.
Okay, Doktor.
Okay. Okay, kalau tak ada apa-apa, I think that's all for today. Okay, I owe you one more answer for the last method, also thresholding. Okay, so I hope kita akan jumpa lagi on 11 for your final exam paper. Okay, I think that's all. All the best. Good luck. Untuk yang part Dr. Daniel, you need to read. Okay? Okay, that's all. Thank you. See you on 11th. All the best.
Thank you, Doctor.
Okay.